A Zener diode provides constant voltage when operated in reverse breakdown region, irrespective of the current through it and the variations in applied voltage. Thus, a Zener diode can be used as a voltage regulator to provide constant DC output voltage. Zener diode is connected in parallel with the load, and the circuit is also known as a shunt regulator. So this is a circuit of a Zener voltage regulator. Vs is the input voltage, Rs is the series current limiting resistor which limits the current through the Zener diode, Is is the current flowing through Rs, Vz is the Zener breakdown voltage, Iz is the current flowing through the Zener diode, Rl is the load resistance, and the Zener diode is placed across the load resistance, which means that this is also called a shunt regulator. V0 is the output voltage. So you can see that the maximum value of load current happens when the load resistance has a minimum value. So IL max is equal to V0 by RL minimum, and the maximum value of the current flowing through the Zener diode is equal to Pz max by Vz, where Pz max is the power dissipated across the Zener diode. The current Is is given by Vs minus V0 by Rs. Vs minus V0 is the potential difference across Rs. The maximum and minimum values of Rs can be found out as per the equations. So the maximum value of Rs max equal to Vs max minus V0 by IL minimum plus Iz max. This means that Vs will be having a maximum value. Minimum value of Rs minimum is equal to Vs minimum minus V0 by IL max plus Iz minimum. That happens when Vs has a minimum value.
So the line regulation determines the amount of load voltage changes and the source changes. In ideal case, a line regulation must be 0, but there will be some voltage change at the output. So the percentage line regulation is given by the change in output voltage by the change in input voltage into 100, expressed as a percentage. You can see that when the input voltage increases, the output voltage also increases. It is not remaining constant. Load regulation graph is plotted with load current along the x-axis and the output voltage along the y-axis. So this is a graph of load current versus the output voltage when input voltage is remaining constant. Load regulation determines the amount of change in output voltage when the load current changes. The percentage load regulation is expressed as V no load minus V full load by V no load into 100, where V no load is the no load output voltage and V full load is the full load output voltage. So full load means the output is fully loaded, that is the load current is maximum. So you can see that in the graph when the input output current increases, the output voltage decreases, which means that this is the full load V full load output voltage, this is a full load current. So when the current is at full load, the output voltage, you can see that the output voltage is decreasing than when the IL is 0. Thank you for your patient listening.